Hi, welcome to my channel JaberTime, where I do math videos simplified with examples from algebra to calculus and differential equations. This is my first video for college algebra, and I have two more coming right after this. Starting this semester, I'm teaching or I'm focused on college algebra and calculus 3. So the plan is by the end of the semester, I will have all the videos for college algebra and calculus 3. It's kind of hard to promise you that I'm gonna have them all by Tuesdays and Thursdays every week and so on. But as you could see, today I'm recording 3 videos, and if I have more time, I will be planning to add or write notes for the 4th video tonight. Hopefully I'll record maybe tonight or tomorrow another one. So if you're here and this is your first time, I'm just telling you that there is more and more and more videos coming in the coming weeks and semesters. I just started my channel about 4 months ago, and I improved a lot since the first video, and I am so committed to those videos and converting my notes, my lecture notes, to YouTube videos simplified with examples, as you could see. I've been teaching since 1987, and I think it's the right time for me to convert my files that are sitting in different notebooks and different file cabinet folders to videos on YouTube. I will be adding more playlists as I go. 2 weeks ago, I just finished Calculus 1 playlist. So in the coming future, I'll be adding more to Calculus 1 as needed. I will be adding more playlists for math activities, math riddles, and sometimes apps that are needed for education, teaching, and learning. All right, let's get into it. The first video for college algebra, we're going to talk about the real number system, R, and the order of operations, properties of real number system or set. So in the real numbers, we write it this way, kind of like a different font than just capital R with 2 lines in the front. We have the natural numbers, N. Then we have the whole numbers, W. We have the integer numbers, I. Rational numbers, Q. Irrational numbers, Q prime. So what's the real numbers and algebraic or algebra essentials? It is often said that mathematics is the language of science. If it's true, then an essential part of the language of mathematics is numbers. Farmers used stones or markers to signify a single quantity. We start with the natural numbers, which is called the counting numbers. 1, 2, 3, all the way to infinity. When we write 3 dots right here, it means like all the way to infinity. We can't just, display them all. So that's how we write the set of natural numbers, or called counting numbers. If you add the 0 to it, we call the new set, whole numbers. So whole numbers will have a 0. If sometimes you get confused which one is which, because I used to get confused, but whole has an O in it, and here's a 0. So that's one way. Sometimes, in math, in remembering names, remembering formulas, if you make a connection to something that might help you to memorize, if you call it that way, do it. So natural numbers are counting numbers. Whole numbers has a 0 in it on top of the counting numbers, all right? If you add the negative numbers all the way to negative infinity, we call it the set of integers. So what's a set of integers? It's the counting numbers, the positive integers, including the 0, including the negative numbers. You could tell from now that the natural numbers is a subset of the whole numbers, and the whole numbers is a subset of the set of integers. So one lives into the other one. This is the one controls both. Now we come to rational numbers. Well, some numbers are not like 5 and 6 and counting numbers or integers or positives and negatives, only like pure integers. So we end up with fractions. Any number that can be written as a fraction is called rational number. For example, in the counting numbers, we have 5. 5 could be written as 5 over 1. So any counting number or any integer is actually also a rational number. So we started by natural numbers, then whole numbers, then integers. Now we build the bigger one, including the decimals, if you want to call it that way. We call it rational numbers. 5 could be written as 5 over 1, could be written as 10 over 2. Just another way to say it, all right? Every natural number, whole number, and integer is also a rational number with a denominator of 1, which I just mentioned earlier, all right? Every rational number can be written as a decimal, a repeating decimal, or terminating decimal. Here's an example. 4 over 11 is a simplified fraction. If you use a calculator, the calculator will kind of like indicate to you that it's 0.363636. They're not gonna put dots. I wish they do in calculators, but you could see the pattern that it's 0.36. The 36 repeats, we put a bar on top of it. Terminating decimal, 15 over 8 is 1.875, and it stops right there. Half is a terminating decimal. It's just exactly 0.5. 1/3 is a repeating decimal. You can't in real life divide $1 by 3 evenly, or divide by 3 and write it down exact. Like if you have 3 kids and you want to break $1 even, being fair, I mean, to the 3 kids, you can't. You start by maybe 3 dimes to each, then 3 cents to each. Now that's like 99 cents. So what do you do with the last cent? Mathematically, you write decimals, but in real life, it's sometimes not practical. But you get my point. So on the other hand, as you can see, I'm breaking the page to pieces, and that's my style of clearing notes so you could stay focused with me. And I write notes before I start recording for 2 benefits. One of them is I could slow down, write clearly to the best that I can, even though I don't have a very good handwriting, as you could see, and cover more material in less time. So I'm saving you time, and I'm covering material more. Most of YouTube videos for math, they do examples, like a problem, 2 problems, and so on. My style is a little bit different. I'm covering the whole thing. So I'm doing it like a course, not just like videos, all right? Lectures with examples. That's what I'm doing. It takes a lot of time to make those notes, as you could see, but I do enjoy it. I do like what I do, and I'll just keep going. If this is your first time watching this video, I would like you to be patient with me, because I can't be committed to make those videos like every Tuesday, for example, or every Tuesday and Thursday. They are time consuming. It takes a lot of time to prepare. It takes time to record and edit and upload, and there is more into it, trust me. Sometimes after I record, it ends up that I need to go back and record again because something went wrong with the video. Like I have two videos. One of them is a slides and one of them is recording myself, and sometimes the video that gets recorded by myself gets frozen, so I have to re-record. Anyway, staying with the topic, irrational numbers cannot be expressed as a fraction of two integers. They're not rational, they are irrational. We write it this way as h such that, this vertical line means such that h is not a rational number, as simple as that. So if it cannot be written as a fraction, it's not rational. If decimal form, it's not repeating or terminating, it's irrational. So what do I mean by this? Let me give you some examples. If you see that I have a lot of things to read here and I skip reading because I want to save you some time, I want to expose you to more examples, you could always take this as an advice. Hit the space bar. That means that will stop the video. Hit the space bar again on the keyboard. That will play the video. So the space bar plays like a remote control. Pause and play. If you want to speed up or move forward a few frames of the video, just hit the right arrow. If you want to go back a few frames, hit the back arrow. Just a tip, because I can't read everything here and call it like I'm teaching online, but I would like to add more and more examples instead of like 2. Rational numbers. Square root of 25 is 5. That's an integer. Could be written as 5 over 1, as I mentioned. 33 over 9 is 11 over 3 simplified, or decimal form 3.6 repeating. Repeating means rational. Terminating means rational. Keep that in mind. 17 over 34 is half, which is 0.5, terminating decimal. This simplifies to 4, terminating decimal. This simplifies to a repeating decimal. As you can see, I'm not reading the whole thing. There's no need. This right here is a terminating decimal. This right here is a repeating decimal. So what's irrational numbers? They look like square root of 11, square root of 2. If you use a calculator to evaluate square root of 11, you get 0.303303330, and it keeps going. But you can't write 0.3 with a bar on it. You can't write 0.3033 with a bar on it. It's not true. Okay, so it's not clearly what is repeating. So we call it not repeating. And also not terminating, it keeps going. It doesn't stop. One more time, I wish the calculator could show that there is 3 dots, but they don't. Maybe I'll make one myself. I'll invent a calculator, maybe that will do that. So, I have a mistake right here. Oh, no, that's not a mistake, sorry. Square root of 11, I want to test it, by the way. I have, for some reason, 2 answers for this one. That's called mistakes. So I'm doing square root of 11 on my calculator. Yes, this is square root of 11 is right here. That's not square root of 11, all right? Square root of 11 is 3.3. This is true. This is true. This is not this one. That's like another example. I went back to square root of 11 just to, with the calculator to show you. Look, 3, 1, 6, 6, 2, 4, 7, 9. You can't tell what comes after 9. So it's not repeating. And it's not terminating. All right? Moving on. More examples. 17 over 34, which is half. Rational, not repeating as a decimal form. Irrational numbers, more examples to stay focused because that's the new part or the new topic. Square root of 2 is one of the famous ones to start with. Take a look. 1.414, 2, 1, 3, 5, 6, 2. So what comes after 2? Do you think it's 1? You can't tell. You can't convince me that it comes as 1. So that's called non-repeating, non-terminating, or differently, or in short, we call it irrational number. Pi is a famous one. Nothing repeats or terminates. Square root of 5. Square root of 5 over 2. Well, if square root of 5 is irrational, multiply by 2, divide by 2, do whatever you want. Now you have another irrational number. So what's a set of real numbers? Given any number n, we know that n is either rational or irrational. It cannot be both. You want to keep that in mind. Okay? It's either rational or irrational. It's either terminating or repeating, that's one side, or none. It's not terminating and it's not repeating. The sets of rational numbers and irrational numbers combined together make the set of our system, which is called real numbers. Now I could move on and go off topic and talk about besides what is not real, but because I have notes, that helps me stay focused with you guys, and instead of like flipping pages or looking at my notebook or so. Here we go. Another comment that we need to know, which is 0 is neither positive nor negative. You want to keep in mind that 0 is neutral, okay? It's not positive nor negative. This is a quick graph by hand. I usually do my graphs by hand. I don't like to use softwares or use images to the best that I can. It feels like more natural. You start with n, counting numbers. If you add the 0 to it, it becomes a bigger circle. It looks like whole numbers, or it's called whole numbers. If you add the negatives to it, it's integers. If you add the fractions and decimals, it's called rational. Outside of this, right here, it's called q prime, which is irrational. Pi and square root of 2 were given to us as examples. Everything here, rational, and outside it, which is irrational, combined, it's called real numbers. And the definitions are right here again for you, okay? So this is part of this, this is part of this, this is part of this. Q controls all of these. On the other hand, we have irrational numbers. Both q and q prime combined will make the set of real numbers. Here's some practice. One more time, I'll go over one or two to save you some time. You could hit the space bar and take your time and study it. And if you have any concerns, any questions, you could leave them down below in the description, and I'll see if I could get back to you. I'll do my best to get back to you and answer any questions or comments that you have, guys. But in the meantime, let's go. Square root of 36, which is exactly 6. That's a natural number, a counting number. Yes. It belongs to the bigger set with a 0, right? It's a whole number. It's an integer. It's rational. I could write 6 as 6 over 1. It's not here. So if it's part here, it cannot be also here. Like this guy here is irrational. Nothing here is with check mark, nothing. Because if it's irrational, it cannot be one of these guys. These guys are for the rational numbers or the integers, you know, they all belong to the bigger one, which is rational. Square root of 73 is 8.544. I believe this is 0, then 0, 7, 745. It's not terminating and it's not repeating. One more time, it doesn't show that there is 3 dots right here, but it's not terminating. Now, as another example, here's negative 6. Negative 6 is an integer. It's not a whole number. And it's not a natural number. So it belongs to the set of integers. But any integer could be written as a fraction, so it's irrational. Which means it's not irrational. If it's rational, it's not irrational. I think you get my idea. One more time, if you need more to take a look at these examples, hit the spacebar to stop the video and hit the spacebar to go back. Let me move on for more notes. Order of operations, which is most of the students, they use it as PEMDAS. Formally speaking, we say when given a mathematical expression, simplify it using the order of operations. Now, everybody in the whole world follows these. Calculators are programmed with these. So if you type in the calculator 5 minus 2 times 8, the calculator will do the times first. It will. You could test it yourself. Now we have to follow. You can't say like, oh, I'm in a different country, I don't like this, I'm gonna subtract before I multiply. You cannot do that. We all follow the same rules and we all agree in math. We might not agree on other things, but when it comes to math, the whole world agrees on it. 1 plus 1 equals 2. Nobody's gonna argue with you unless if they wanna joke around about 1 plus 1 that is something else, like 3. I've seen some jokes and some riddles about that, but inside it there is a mistake, or there is a kind of like a catch why they're trying to convince you that 1 plus 1 does not equal to 2. So we do the grouping symbols first. We do the exponents and radicals next. Then we do multiplication and division. If there is no grouping symbols, we go from left to right. Finally, we do addition and subtraction. If there is no grouping symbols, we go from left to right. Let's take some examples. Because this is an introduction to college algebra and it's like a symbol topic, I'm not breaking it down to too many pieces and slowing down. There is no need. I don't think so. So here we go. Use the order of operations to evaluate the following. Now, we have set of parentheses right here, and we have set of parentheses right here, or grouping symbols. So we take care of them. 3 times 2, that's not 3.2. 3 times 2, that's a 6. 6 plus 2 is 8. Then I'm going to take care of the square. So I'm going to use the exponent, make it 36. Then I have subtraction and I have multiplication. So I'm going to multiply first. Multiplication first. 4 times 8 is 32. Finally, we subtract and we end up with 4. Let's take another example. I have now a fraction, a subtraction, exponent, square root, and so on. Let's take a look. Well, as a common sense, to find the square root of something, you need to know what that something is. So it's called grouping symbol, radical, all right? Inside it, 11 minus 2 is 9. That's part of the game. Square root of 11 minus 2 is 11 minus 2 to the power half. That's one way to say it, as to show you or enforce the concept that this is called grouping symbol. All right? 9 to the power half means square root of 9. If for some reason you can't find the square root symbol on the calculator, test it with the power half. That's going to give you the same answer. Trust me. Square root of 9 is 3. 9 to the power 1/2 is 3. Now, we took care of this as a 3. Now, to divide, you can't divide yet. You have to find what's on top and what's on the bottom side. It has to be clear to divide. That's called grouping symbols too. Before that, to evaluate the numerator, there's a multiplication or exponent here, powers, and subtraction. So we take care of the power first, or the exponent. That makes it 25. Then we subtract. Why do we subtract before we divide? Well, because 25 minus 4 over 7 is actually a grouping symbol idea. You have to finish this to be able to divide. So we do have grouping symbols, but it's not mentioned as parentheses. Right? So we have to divide, or finish the numerator before I divide. We end up with 21, 25 minus 4. Now we have the division and we have subtraction. Division comes first and it's powerful than subtraction. and we take care of it. 21 over 7 is 3. 3 minus 3, finally subtract, and the answer is 0. Here's another example. This is absolute value, which is like a grouping symbol, like a square root package together, you could call it that way. And I have a multiplication with a grouping symbol right here. So if you take care of this first, that's a 3, as you can see. 5 minus 8 is -3, so I'm working inside. Here's another hint. Every time you have grouping symbols, work from inside out. That's how it works. So that's a -3. Apply the absolute value as a second step. That's a 3. This minus is right there. I try myself in my notes to align things. This minus right here went away because of the absolute value. But the outside one did not cancel, of course. I have multiplication and addition and subtraction. I take care of multiplication first. That's right here. That's a 9. Then I have subtraction and addition without grouping symbols. So we go from left to right. We subtract first. 6 minus 3. Underneath it, in the middle, I wrote 3. Trying to align them, as you could see. Bring the plus sign down. Bring the 9 down. So all what I'm doing is I'm evaluating subtraction first, or doing subtraction first. Finally, we add, and the answer is 12, and we're done. Another example. I have a major fraction bar, and I have on top a product, and a product, and a power. Well, to do the division, I have to find everything on top and everything on the bottom side. I have to, but looking at top and bottom, we start with the exponent or power. That's a 9. That's a product. That's a product. We take care of products. That's a 6. And 2 times 5 is 10. Now this to me looks like 14 minus 6 divided by 10 minus 9, as you could see right here. I can do the subtraction. Well, to divide, I need to group the grouping symbols. Grouping symbols comes before multiplication and division. 14 minus 6 is 8. You might say like, oh, you subtracted before you divide. Well, yeah, because of the grouping symbols. All right. 10 minus 9 is 1. Divide. Finally, do the quotient, and that's 8. One more example. Inside parentheses, those are like a bigger set of parentheses to distinguish. Sometimes it's kind of hard to have them the same size. We use brackets. So this is inside, this is the bigger one outside. My advice was earlier, like, work from inside out. So this is inside, and we work out, and so on. Take a look. Inside parentheses. 5 minus 3, 15. 6 minus 3, 3. Power, it's not going to make a difference here. We could do the power first. 4 squared is 16. Subtraction comes at the end, inside those grouping symbols. 3 minus 16, negative 13. Multiply right here, and multiply right here. Finally, we deal with the addition and subtraction. This here was subtraction, but it changed to plus. So I have add. So we go from left to right. 105 plus 26. Then add 1 to it, and the answer is 132. Here's some properties. I could skip this, but why not? I'll take the time to write the notes for you guys, because I keep saying it. I don't like my videos just to be 2-3 examples and call it teaching videos. My videos are more like teaching videos with examples. Commutative property for addition, a plus b equals b plus a, which is true. 5 plus 2 is the same thing as 2 plus 5. In multiplication, A times B is the same thing as B times A. Associative property for addition and for multiplication. A plus B plus C is the same thing as A plus C, B plus C. Kind of like I'm reading it the same way, but you could see from here, you could start from right grouping or you start from left. It doesn't make any difference. Same thing or concept for multiplication. Now this is one that goes with both addition and subtraction. It's called distributive property of multiplication over addition. A times B plus A times C. Identity property. In addition, there is the number 0 that we call the identity element. If you add 5 plus 0, add 0 to 5, you're not going to go anywhere. In multiplication, it's the number 1. If you multiply 5 times 1, you're not going to go anywhere. That's called the identity element or the identity property. Inverse property. Well, what do I need to add to 5 to take me to the identity element 0? You add the opposite. Here, we don't say add, we say multiply. What do you multiply a number 5 by to get the identity element 1? You multiply by the reciprocal. That's called inverse property. Like undo. So if somebody multiply by 2, to undo, you divide by 2, like multiply by half. Alright. Now, formulas and expressions. A right circular cylinder graphed right here. As you can see, I like to enhance my videos with graphs by hand to the best that I can. And I think they do help excuse me, understand what the problem is talking about. A right circular cylinder with radius r and a height of h right here has the surface area S in square units, given by the formula S equals 2 pi r times r plus h. Now our topic here is using formulas, but if you wonder why this is looks like this, it's actually, if you cut this and open it, it's a rectangle. That's a side surface, and I have a circle on top and a circle at the bottom side, pi r square, pi r square. That's when you multiply r times r, you get r square, and the story continues. So that's one way to look at it as a formula. Find the surface area of a cylinder, we know the formula, with given radius 6 inches and height 9 inches. Leave your answer in terms of pi. Well, here's the formula right here. Plug in 6 for r, plug in 6 for r, plug in 9 for h, for the height. Now we need to apply or use the order of operations. We do the inside part, grouping symbols. 6 plus 9 is 15. And everything after that is just multiply. You could move the pi up front, commutative property, you could do whatever you want. But if at the end you have 2 times 6 times 15, which is 180, and they told me to leave the answer in pi, so it's 180 pi. One more example. We're almost done, by the way. Simplifying algebraic expressions. How do you simplify 3x minus 2y plus x minus 3y minus 7? Well, the x's are not next to each other, and the y's are not next to each other. But if I look at these two terms, and I switch them around, they become x first and minus 2y after. This is called excuse me, commutative property of addition. That's why we need those properties to refer to and use. Now I could combine these two. We call them like terms. That's a 4x, 3x and one more x. We could combine these two, take away 2y, and also take away 3y. That's take away 5y. This right here, underlined in pencil, is written for you here, that the minus 2y plus x is the same thing as x minus 2y. Here's another example. This time we're using the distributive property. Multiply 5 times and 5 times. Don't forget the minus sign, because let's take away this whole thing. So the best way is to go in with the minus 5, not the 5. Negative 5 times 3 is negative 15. Negative 5 times negative x, that's positive 5x. One more time, we're gonna use the commutative property to move the x's next to the other x's. A plus b is the same thing as b plus a. Group the like terms. 2x and 5x is 7x. Negative 15 and 4 will simplify to negative 11, and we're done. One more example. A rectangle with length L and width W has a perimeter of P where it's the four sides, length and width and length and width. If you want to simplify this, you could switch these two. I'm underlining them for you, and that's called commutative. So instead of saying W plus L, you could say L plus W. It's the same thing. Then combine the like terms, and you could also pull the two outside. Now when we factor out, it's actually the distributive property, because that's being factored, that's not being factored. That's still the same topic. I know some students go like, what do you call this step? Well, it's factoring, but there is no property that's called factoring. It's distributive property. Alright, so I think that should do it for the first video. I'm recording 2 more videos after this, and that's my start for college algebra. If you like this video, stick with me, and you're gonna have the whole college algebra videos in the coming weeks and months for this semester. I'm gonna have it all for you guys. Just be patient with me, and you're gonna have everything, notes and examples saved and in order. Alright? Thank you for watching, and I'll see you the next time. Thank you. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.